My name is Frank Lee. Today I'm going to share with you how IBM cognitive infrastructure is being put together to fight COVID-19 and the underlying infrastructure which is connected together by this architecture called high performance data and AI. We're facing unprecedented moments of humanity challenge that touches on every aspect of business, technology, culture, and society. The pandemic has caused tremendous impact on our society. And we're using high performance technology, information technology, to deploy against this problem at massive scale. The goal here is to really deliver fast time to results and time to value in delivering technology to help attack the COVID-19 virus. These are the 6 areas that we think can bring value quickly to this fight. We're using AI and high performance computing technology to look at the virus sequence, to simulate the protein structure of the virus, to look at how we can help develop the vaccine much faster, using AI to diagnose medical images, to fuse the data together coming from, for example, literature, news, to help researcher spot the pattern faster, and also to be able to inspect the instruments and the diagnostic equipments quickly in the field and remotely. Now, to get there, there's some challenges we have to address first, and then we summarize them here in 5 different categories. And these also tend to be the pattern that many of our customers, partners address to us in terms of their journey to the cloud or AI. So in this, not necessarily in this sequence, there are data challenges, lots of data that needs to be handled very fast and properly accessed and archived. There's application challenges, thousands of applications, workloads needs to be properly managed. Ease of use is always a top goal for lots of researchers, but it oftentimes is met by real world challenges of getting the system and platform being usable or useful. Performance is a very big goal, high performance especially, to be able to scale up and out to deliver a system of capability to address the challenges or the problems. And of course, the last one is cost. Right? We can do all these things. If we can address all of these things, and the system is very costly, it will still be out of reach for researchers and users. So to address these problems, we are working with clients, partners worldwide. Here's an example of us working with Washington University and Vanderbilt University together and produce a prototype of using IBM Power System running AI-enabled algorithm to process MR images 20 times faster than a traditional system, reduce the cost, increase the performance, and make this easy to use by a researcher such as a radiologist. We're also working with Seizure Medicine. This is the leading medical research center in Qatar to implement precision medicine using genomics and high performance sequencing and analytics to process the data extremely fast and in high throughput. Again, high performance, low cost, and ease of use. So these 6 tasks, genomics, simulation, structure analysis, medical imaging for diagnosis, data fusion, and quality inspection are the focus area we believe can bring time to value, scalability in terms of getting the questions answered quickly, getting diagnostic made faster, and ultimately to be able to outcompute and outrace the COVID-19 virus, which is mutate at a frequency that is exceeding our current capability. So we need to speed up, scale out, and deliver this capability to fight the virus. So how can we get there with the reference architecture to help build this system? In the past, all these systems, such as genomics or imaging, are built in silos. They are optimized on a vertical pillar, if you will. But now we are looking at building a platform with horizontal capabilities, such as handling the data using Data Hub, or orchestrate the compute running jobs on GPUs or power CPUs extremely fast, but be able to scale this out using the software-defined infrastructure or architecture we call HPDA. And with this underlying architecture, we can then build all kinds of different models, applications, workflows, AI algorithms, while sharing this infrastructure and to be able to run all these different medical task, especially we're talking about here, concurrently in the same environment or in an optimized way. This is how we can get to the scalability, the speed, and the smart we need to develop these medical task capability to help with the COVID-19 fight. So the goal here really is to ask us a question: how can we be smarter? How can we innovate faster? How can we deliver a capability that enable our frontline researchers and medical workers to fight the COVID-19? It's not just this particular pandemic, but it's a long-term goal and a journey to enable us to be able to build these infrastructure for the long-term success of research and drug development. So our goal here is to help and deliver these fast insights with great efficiency and address these challenges I mentioned: data, application, ease of use, high performance, low cost. To learn more about the HPDA solutions and the underlying infrastructure building block, please visit these websites. Thank you for your time.